we're going to be looking at the Designing Hot and Cold Packs lab. This is going to be for day one only. So day one, if you guys are missing it, you'll be able to do it from home. Or if you guys are in class right now watching this video, it's because I had to jet and you guys are with my lovely assistant walking you guys through these steps. Okay, so this is day one only. Again, if you guys are going for day two or day three, you guys will have to make those up with me. Okay, so for day one today, we're going to learn a little bit about exothermic and endothermic reactions and how they work with chemistry to produce heat, or to, if we're looking at like a cold pack, to get cold. Okay, so your learning targets: I can identify chemical reactions that release energy, which are called exothermic reactions, okay, and absorb energy, which are endothermic reactions. Okay, so first things first is, if you guys haven't completed your bell ringer, go ahead, pause this video right now, complete your bell ringer, and then when you're done, you can come on back to this video and we'll finish up day one. Okay, if you guys are done with your bell ringer right now, I want you guys to leave your computers closed, because we're going to go ahead and talk through what an exothermic and an endothermic reaction is first, before we talk about what you're going to be doing in your lab. Okay, so when we have chemical reactions, and we're going to learn a lot about these in chemistry, okay, sometimes in order for a chemical reaction to occur, the chemical reaction needs heat, okay, or energy to occur. So it's going to steal its energy from its environment. So if you guys recall back to our very first day of this unit where we did the thermal energy demos, okay, we talked about why certain things feel cold and why certain things feel hot. So just as a review of that, human beings can't feel temperature. When you guys feel hot and cold, what you guys are feeling is either energy transferring into your hand or energy transferring out of your hands. So if you guys are holding a hot cup of tea, okay, you guys have way more energy in that cup of tea than you do in your hands. So when I'm holding that, that energy is going to go from my hot tea, which has more energy, to my colder hands, which have less energy. So always from more energy to less energy. And then when we hold that hot cup of tea, okay, we have so much energy coming into our hands that it feels hot. Okay, if we're talking about like a hot stove, that hot stove has so much more energy than our hand does. So when we touch that hot stove, that amount of energy that comes into our hand in that quick amount of time is actually going to cause damage. So that's where you guys get burns. Same with like energy from the sun. If you guys are out in the sun without sunscreen on, okay, that energy from the sun is going to cause a sunburn. Okay, so when you have a massive amount of energy going into your hands like that, it can cause damage. Okay, same with removing a massive amount of energy. So if we flip the script and talk about holding a snowball in our hands, okay, we are actually feeling cold, not because we can feel temperature, but because we are losing energy. Our hands have more energy than that cold snowball does. And so the energy is moving from our hands into the snowball. And when we lose energy from our body, it feels cold to us. It feels cold to the touch. Okay, so when we talk about chemical reactions, there's some reactions that need energy, and there's some reactions that have a lot of stored up potential energy in the bonds. So when the chemical reaction occurs and those bonds are broken and stuff's rearranged, which we're going to talk about in our chemical unit, or our chemistry unit, they release that potential energy and we can feel the heat from that. So let's take, for instance, a hot pack here. Okay, so my lovely assistant, okay, is going to go ahead, she's going to pop that hot pack, she's going to shake it up. Inside, I can feel like there's some kind of little powder here. I can also feel a second bag with a liquid in it. Okay, so what we're going to do is we're going to mix those chemicals into a chemical reaction. This is going to be an exothermic reaction. So she's going to pop that, and then she's going to pass it around to you guys while you listen to this video. Okay, what is happening in that chemical reaction is there's potential energy stored up in the bonds of the chemicals in here. And when we mix them all and get them in that watery environment, okay, that energy is going to be released from the chemical reaction. So when we hold this, okay, this is going to have more energy than our hands are. The energy is going to move into our hands, and it's going to go ahead and feel hot. That's an exothermic reaction. If we talk about Latin root words, exo means on the outside. Okay, so if you guys think of like an exoskeleton on a bug, they don't have a skeleton inside their body. Their skeleton is on the outside. Okay, so what we say when we say an exothermic reaction is that heat is coming out of the chemical reaction. So we can feel that energy or that heat being produced. You guys might also see like light being produced. That wouldn't be called an exothermic reaction, because thermic talks specifically about thermal energy or heat. But those are different ways we might see energy being produced from stored potential energy in the bonds. Okay, so if you guys need a second while you're still passing this around, pause the video, make sure everyone gets a chance to hold the hot pack. Okay, and then when you guys are done with that, you guys can hit unpause on this video, come on back to feel the cold pack. Okay, so same thing, my lovely assistant. I can feel kind of little beads in here. I feel some other kind of maybe powder possibly. And then same thing with the cold pack. I feel a little packet of water. So I'm going to pop that open. I'm going to have my assistant pass this around to you guys so you guys can take a second just to feel the cold pack. Okay, this is going to be called an endothermic reaction. In order for this reaction to take place, this chemical reaction or these chemicals need to steal energy from their environment. Okay, so when we mix these chemicals and pop it open, okay, they're going to start stealing energy from its environment. So when we touch this, okay, it's going to be stealing our energy from our hands. So the energy from our hands are going to be moving from our hands into this hot pack to fuel the reaction. Okay, the more energy it steals, kind of the colder it gets. So you guys might feel it get colder over time because it's had more time to just steal energy from its environment, whether that's the air around it. Okay, so the air around it's going to lose energy. And then all that energy isn't going into making the hot pack hot. It's going in to make the chemicals. Okay, so when we touch this, it feels cold to us because we're losing energy from our hands going into that cold pack. So that's going to be an endothermic reaction. So endo means in, okay? So we can think of those kinds of things. So again, take a second, pass around the cold pack, just feel it for a quick second. We don't need to mess around with it for very long. And then once it's done, send the hot and cold pack forward and we can move on with this video. Pause if you need. All right, so for today's reaction, you guys are going to be using chemicals, so obviously you need to have your goggles and aprons on once we start this lab part until the end of class. Please do not take your goggles off at no point. Should anyone have to remind you guys to put your goggles back on. Okay, so do not touch or taste the substances. We're not going to bring any of the cups to our face. We're going to be mixing them today in Ziploc baggies, so once we mix our chemicals inside of our Ziploc baggies, we will not open them again. So we won't be able to smell the reaction. We won't be able to have any air coming out. We won't be able to taste it. You shouldn't ever taste anything in the lab. If you guys are doing these things, you just will be done with labs for a year, because from now on, we kind of have a lot of different labs that you guys need to demonstrate some lab safety. So I need you guys to be super responsible with this, especially if I'm not here for this lab part today. So please be on your best behavior. Okay, at the end of class, because some of these substances can irritate your skin, everyone needs to wash their hands, especially if you guys are before lunch. But everyone needs to wash their hands before you guys leave today. You guys also need to wipe your tables down and you need to clean your trays off. There's going to be a whole list on the sideboard that you guys need to complete. You guys will be working with partners of 3. So you guys will each have a part, like partner 3 is going to do throwing all the Ziploc baggies out. They're also going to be the one who wipes the table down at the end of the day. Partner 2 is going to refill the water pitcher at the end of class and restock to make sure you guys have 6 clean plastic baggies or Ziploc baggies for the next class. And then partner 2 is going to take everything off the tray, dump any loose chemicals in the trash, wipe the tray down and put everything back on the tray and then put the tray back. Okay, and then everyone needs to wash their hands and put their goggles and aprons up at the end of the day. Okay, so for this, what we're essentially going to be doing after today is we're going to collect data to kind of see whether we have endothermic or exothermic reactions. Okay, and then the data you guys collect today, you're going to use to help you guys in day 2 and 3 to design the most effective hot or cold pack. So half the class will get a cold pack. Half the class will have to do a hot pack. It's going to be kind of first come, first serve. Okay, and your criteria for that is you want your cold pack to reach the coldest temperature possible if that's what you're doing, or if you're doing a hot pack, you want to have your hot pack reach the highest temperature possible. So not today, but tomorrow you guys will actually be doing some quantitative analysis where you guys are going to be taking the temperature and seeing what your either highest or coldest is based on whether you're doing a hot or cold pack. So that's going to be the first criteria, is to get the best temperature for your guys' scenario. Okay, the second one is to use as little substance as possible. So if you were doing this for a business, you guys are going to try to kind of minimize the cost by not maximizing the amount of substance you use. So you're going to try to do this in the most efficient manner possible. Okay, so for your guys' lab today on day 1, what you guys are going to do is just collect some foundational data and observations to help you guys decide, all right, if I want to make a cold pack, which chemicals do I need to use? If I want to make a hot pack, which chemicals do I need to use? So today you guys are going to start by isolating each of the 3 substances on your tray. So you have 3 cups, and each cup you either have baking soda, calcium chloride, or citric acid. So you're going to first start by mixing each of those with water to see if they react at all on their own to either have an exothermic or endothermic reaction with just water. Okay, so here's what your guys' test will look like for all 6 tests. Okay, so test what happens when you mix different combination of substances in a plastic bag. Use these tests to explore substances that you may use in a hot or cold pack design. In each test, mix no more than 2 solids. So at no point will you guys mix the baking soda, the calcium chloride, and the citric acid in one baggie. Okay, their first 3 tests will just be each solid plus water by itself. And then you guys will do combinations of 2 for your next 3 tests, and that's it. You're not going to mix all 3. You will not get good results for it that are going to be helpful to you guys moving on to day 2. Okay, so clearly label your bag. You guys really don't need to do that. You can just mix one at a time and then just throw it out when you guys are done. If any of your bags look like they might explode, please just get them to the garbage can. That way, if they do explode, it's going to happen in the trash. You're not going to have to worry about getting it on your hands, on your clothes, having more mess to clean up at your table. Please make sure you guys are staying clean with those as well. Do not open them once you've sealed them. Okay, so for solids, you're only going to ever use a half a teaspoon leveled out. So you don't need to use your finger to level it. What you can do is you can scoop with a little half teaspoon and then just over the cup, give it a little gentle shake. Okay, to level it out, and that's good enough. It doesn't have to be perfect. You're going to add that first to your plastic bag, and then you're going to measure out 45 milliliters of water. All of you guys should have 50 milliliters of water, unless you guys have tray 12. I would just avoid sitting at table 12 so you guys don't have to use tray 12. I just don't quite have enough 50 milliliter graduated cylinders, so that one has 2, so you'd have to do 2 different measurements of water to get 45. So again, I would just not use tray 12. Everyone else has 50 milliliter graduated cylinders, so you're almost going to go to the top of that. So look for the halfway increment between 40 and 50. Okay, so once you guys have your solid in your bag, you guys are going to then measure out your 45 milliliters of water. If you run out of water, just use cold water from the tap, okay, or try to use room temperature is probably a little bit better, so that way it's not the water influencing what you feel for your temperature. Okay, and then you're going to add that water in. You're going to quickly and carefully press the air out of the bag, so try to get as much air out of the bag as possible. A lot of these reactions are going to produce gas, and so you want to be able to kind of see how much gas it produces, just a little bit, a lot. So make sure you kind of press all the air out of the bag right after you guys mix them, seal it shut, and then once it's sealed shut, it does not come open again. You do not open it to taste it, smell it. You shouldn't be doing those things anyway. Mix them through with your fingers, and then you guys are going to take observations visually. Okay, what's happening? What do you guys see? Is it producing bubbles? Is it filling up with air? Is it changing colors? Are those substances dissolving? Do you see any bubbles forming? Like, what do you guys observe with your eyes? Okay, and then feel them with your hands again on the outside of the bag. Obviously, we're looking for endothermic or exothermic reactions. So if it's an exothermic reaction, it should be producing heat and could potentially be a substance you want to use if you're designing a hot pack. If it feels colder than the original water that you guys put into it, then it might be a substance you would want to use for a cold pack. That's going to be an endothermic reaction. It's stealing energy for your hands in order for that chemical reaction to occur. Okay, observe what happens and record the results. So again, once you guys seal those up, don't open them again. If they look like they're going to pop, throw them in the garbage. Okay, so on slide 5, once you guys get your tray today, you guys will start on slide 5. You're only going to do one substance at a time plus water. So again, half a teaspoon of each substance plus 45 milliliters of water. You guys are going to frame out what you're going to do first. You guys can choose what you do first, like maybe you do the calcium chloride and water, citric acid and water, and then baking soda and water. You're going to do all 3 no matter what. Okay, so it really doesn't matter what order you guys put them in. So write whatever order you guys did here. You don't have to write on the bag, and then write your observations here. Okay, again, keep in mind which are endothermic reactions and getting cold to the touch because they're stealing energy, or which are exothermic reactions that are giving energy to your hands and feeling hot. Okay. And then you guys will move on to slide 6, which is 2 substances in water. So there's 3 different combinations you guys can do. Okay, there's citric acid and baking soda, citric acid and calcium chloride, and then calcium chloride and baking soda. So again, whatever order you guys go in is fine. Just write it here. You guys will put your 2 substances in first. Again, half a teaspoon of each. Okay. Tomorrow you'll get to explore a little bit more of what if I use more than a half a teaspoon? What if I use less than a half a teaspoon? What if I use a half a teaspoon of this, but a teaspoon of this? Okay. That will be your guys' exploration tomorrow. So today we're just seeing if we have endothermic or exothermic reactions with these. So put your 2 solids in first to the baggie, then add your 45 milliliters water, seal it up right away, mix them, and then again, take your visual and touch observations, explain those well here. Again, look for things like, are they dissolving? Are they producing air? Is it getting hot? Is the bag producing a lot of air? Is it filling up fast? Did it almost pop? Is it barely producing any gas? Does it kind of feel the same? Maybe it really doesn't have a temperature change. Okay, so you guys will do your observations there. Okay. And then you're going to start to talk with your group today on slide 7. I'll get there in a second. But I want you guys to all take a look at the sideboard. Okay. You guys will be working in groups of 3 today. I am going to let you choose your groups, but settle down. I know you guys are already giving each other googly eyes because I know you guys. Okay. You guys will be working in groups of 3. You will be with this partner or these 2 partners for the next 2 or 3 days. Okay. So today, tomorrow, and the next day. So day 1, day 2, day 3, you're going to be working in groups of 3 for all of these. So make sure you guys choose wisely. If there's like a good friend that you're like, oh, they're just gone today, but I know they'll be back tomorrow, you guys can definitely snag them for your group. Also, if you guys are watching this from home because you're missing today for day 1, I'm going to post these videos underneath. This is 2025 this year. So I'm going to post these videos underneath the team assignment. So if you guys are gone for day 1, you guys should be able to still collect your data for day 1 and do that. In future years, though, I will have a link where you guys can watch all the videos from home and be able to do day 1 from home if you're gone. Okay, day 1 will probably be the only day that you guys can do from home. Okay, so you guys will get with your group when you guys start today. You guys will obviously complete through slide 6. Okay, on slide 7, okay, you guys are still paying attention right now. We haven't moved yet. We're in our normal assigned seats until I say go. Okay, so what you guys need to think about then as you're going through today's data is, are you going to create a hot or cold pack for the next 2 days? Okay, half the class will get hot pack, half will get cold pack. So it's going to be kind of first come, first serve. So once you guys finish through slide 6, you can come tell either me or the guest teacher, whoever it is, what your group is going to be doing. Again, it might be one of those, all right, everyone's, the first 6 group is taking hot packs. Now you guys got to do cold pack. Okay, if you guys choose a hot pack, okay, you're going to try to reach the hottest temperature possible. Remember that body temperature is about 37 degrees Celsius. So we obviously want that to be a lot warmer than 37 degrees Celsius. We also don't want it to be too warm where it burns our skin, okay? That would be not good for the brand as well. And then you want to also use as little substance as possible because you are trying to save money for a company. Okay, cold pack. If you guys choose a cold pack, you guys are going to be trying to reach the coldest temperature possible. Remember that their body temperature is 37 degrees, so it obviously should be much cooler than that. Water freezes at 0 degrees Celsius. You probably wouldn't want it below freezing as well. And then same, use as little substance as possible. So that's kind of our design cycle. Okay, so for your guys' exit ticket today, with your group of 3, once you guys have finished 5 and 6, told someone, an adult in the classroom, what you guys are going to do for your hot or cold pack. Then you guys will do your exit ticket. Again, if you guys chose hot pack, but you got up there too late and all the hot packs are gone, then you have to do cold pack. Make sure you guys answer your question accordingly for that. Okay, so which type of pack will you design? You'll either say hot or cold pack. So circle your answer there. Okay, and then what do you guys think you guys might do for chemicals for that? So you guys would want to kind of circle based on your guys' data that you saw in class. Which substances will you use in your design to accomplish this? Maybe you guys look back and say, hey, these are the only ones that made it cold. We choose cold pack. So I'm going to circle these substances here. Everyone should circle water because these reactions will not happen without some kind of substrate to dissolve the substances and get their ions mixing. Okay, so everyone has to circle water. Okay, you'll use 45 milligrams or milliliters of water every time. But then of those 3 solids on your tray, which are you guys going to use to either make your hot pack or your cold pack? Okay, and then last part of your exit ticket today, everyone's doing this on their own computers. Even though you're working with a group, because this is 3 days, I don't want anyone being like, well, all of our information was on so-and-so's computer and they're gone today. So everyone's doing this on their own computers. Okay, so why are you choosing these substances? So go ahead, use some data from your guys' slides 5 and 6. We don't have any numbers for data, but we do have good observations. So make sure you guys use that data to explain why. Okay, so that concludes day 1. You guys can go ahead at this point, get with your group of 3, put your goggles and aprons on. You guys can go ahead, collect your data on slides 5 and 6, and then make sure you guys do a good job cleaning up today using all the instructions on the board. Have a good day. Talk to you later.